All right, hello again. This is Mr. Merrifield. We're going to be doing another review. Today we'll be going over solving equations with special cases. And what I mean by that is we deal a lot with these, but sometimes we have cases where the variable we're solving for can have any number at all be the solution. So there's an infinite amount of solutions. It doesn't matter what the variable is, it will solve the equation. We also have these special equations with no solution. And I also want to give you kind of a cautionary tale, a mistake that I see a lot that we're going to try to review, go over the logic of that. So kind of go over, what do you see? We got one solution, infinite, and none. And I'm actually going to fill this in right off the bat. I think you guys are pretty good with the one solution case, so we're not going to go over that one, but again, of course, you'll just see a specific solution. So an example for that, you might get x equals 6. You might see something like that. So let's go over these examples and you'll see kind of what you'll see with infinite and no solution. So we're going to start with this equation here. This negative 2 times the quantity x plus 3 is equal to negative 2x minus 6. So some of you right off the bat might say, Mr. Merrifield, the left-hand side is essentially the right-hand side. And on this one, it's just a distributive property away from seeing that, but sometimes they're going to be a lot more complex than that. It might be 8, 9 steps away from seeing they're the same. So we'll solve this one, see what happens. And I'm actually going to go back and solve it twice because there's two different things that you might come up with that would get you to those infinite solutions. So we'll start by distributing. And I got negative 2 times x and negative 2 times 3, so that gives us negative 2x minus 6. On the right-hand side, nothing really happened. I just got negative 2x minus 6. So now we go through and solve. And this is where the problem kind of takes two different paths that you could take. So for one, you could say, I want to group up all my all my constants on one side. So I could try to move this negative 6 over by adding 6, or this negative 6 over here by adding 6. Or I could deal with the variable. So to start, I'm going to deal with the constants first. So you might add 6 to both sides. And that actually wipes it out, not only on the left-hand side, but on the right-hand side as well. And I get this statement, negative 2x equals negative 2x. And I can divide off by negative 2, but I've already kind of seen that if I take a number, or a number multiplied by negative 2, it's always going to equal to the same thing if I'm taking on the right-hand side, that same number multiplied by negative 2. I could plug in 0, and I'd get 0 equals 0. I could plug in 1 for my x, and I get negative 2 equals negative 2. I could plug in x equals 2, and I get negative 4 equals negative 4. It doesn't matter. X, at this point, could be anything. You can kind of visually see that right there. It doesn't matter what I plug in for x. So you might get something where you only have variables and you're left with something like minus 2x equals minus 2x. And you know, well, x could be anything at this point. But I also could have taken another juncture here. And I'm going to go back and show you that as well. So let's replace my negative 6 back again. And I also could, of course, at this point, I could have said, well, I don't want to deal with the negative 6's yet. I'm instead going to deal with the variables. So add 2x to both sides. And that, of course, takes those 2x's and wipes it out on both sides. They're just inverse operations. What carries down is just negative 6 on the left and negative 6 on the right. And at this juncture, you're basically saying, well, negative 6 equals negative 6. That's true. And you may be saying, well, how do I leverage that to get to a solution for x? Well, you could look at this and you could say, well, let's say I make the statement x is equal to 10. And I say, I want to plug that into this equation. That might seem like a weird statement, but if there's no x's here, I can't plug it into anything. So it still remains negative 6 equals negative 6. I could plug in x equals 1,000. Plugging it in essentially does nothing to the statement. It remains true. And I could go through everything, any possible combination or any possible value for x, and it would still remain true. So what I'm going to say here is, oh, there's the other case or example that might show that I have infinite solutions, where you just have some constant is equal to itself. So if I have something like negative 2x equals negative 2x, that would tell me that's got infinite solutions. It would also be if I just got a constant equals a constant, like if it were 2 equals 2, or here negative 6 equals negative 6. So let's go over another case to look at another one of those special cases falling out. So for that, I'm going to use this equation right here. So what I'm going to do is I'm just going to go ahead and solve. So I got like terms I can combine. Let's combine them here. X plus 2x, that's just 3x, plus a 1. And then I've got 3x, combine these two terms, I get 5. And then I could go through and solve, or I could just look at it. So I've got a number times 3 plus 1. It's never going to equal that same number times 3 plus 5. They're always going to be 4 apart. But to illustrate that, let's just subtract off 3x from both sides. So that cancels out, and I get this statement 1 equals 5. And 1 equals 5, it's kind of like this case where I got negative 6 equals negative 6. This is true no matter what I plug in for x. So x doesn't really affect this equation. I could plug in anything, negative 6 equals negative 6. However, here, I plug in x, it still doesn't affect it, but it affects it in a way that keeps it untrue. So 1 equals 5. That's not true if x equals 0. It's not true if x equals 10. It's not true if x equals 100 million. It is never true. So there's no solution for this equation. If I plug in something to the left-hand side, the right-hand side is always going to be 4 or more, no matter what. So if I get something like this, I know that is fundamentally untrue. So this has no solution. All right, the next example I'm going to go over is kind of a cautionary tale. So it's very easy to get a problem like the one I have here and assume that it has no solution. But as we're going to see, it will. So what I'm going to do here is I'm just going to solve this as normal. I got some distributive property, so I'm just going to distribute that out first on both sides. On the left-hand side, I get 4 times x, which is 4x. 4 times negative 1, it's going to give me negative 4. And I'll do that on the right-hand side as well. So on the right-hand side, I get 1/2 times x. That's just 1/2 x. And 1/2 times negative 8, that's the same thing as taking negative 8, dividing it by 2, gives me negative 4. So what I'm going to find here is if I go through and I solve this, is I can essentially, let's just try to get everything on one side. So what I'm going to do here is I'll start, let's just get the x's on one side. So subtract 1/2 x from both sides. Do that, that cancels out, and I just get negative 4 on the right-hand side. On the left-hand side, I've got 4x minus 1/2 x. I could just think of that as 3.5x. All right, so now add 4 to both sides, and essentially I get 3.5x equals 0. And this is where the cautionary tale comes in, because a lot of you will come here and you'll say, well, that has no solution. 3.5x or 3.5x can equal 0. Not true. So instead, you could ask yourself, or you could tackle this 2 different ways. So first way, you could say, well, 3.5 times a number equals 0. Well, doesn't any number times 0 equal 0? So from there, logically, I could make the statement x equals 0. You could also take it one more step. So here, I just got to undo the multiplication, divide both sides by 3.5. That cancels out. 0 divided by 3.5 is just 0. So I get the statement x equals 0. So my cautionary tale here is if you get something like x equals 0, that's still a solution. It's very tempting to lump it into here and say x equals 0. not a solution. 0 can be a solution. I could have 0 pizzas, I could have 0 bagels, I could have 0 of a lot of things. So hopefully this video helps. I'll post some practice on this, and I'll also post some more puzzles for the week, and I'll see you guys later.